Hello and welcome to B School of AI. In this video, let's talk about RAG, Retrieval Augmented Generation. If you've ever wondered how AI tools answer questions from PDFs, websites, or company data, RAG is the magic behind it. We'll break it down step by step in simple terms, so even if you're new to AI, everything makes sense by the end. Let's first understand what a standard LLM is. Think of it like a closed book exam. Models like OpenAI, Google, Meta, Anthropic, Microsoft, or Cohere are trained on massive amounts of data during training. But once training is done, the model cannot look up new information. It can only answer based on what it already remembers from training. This means it's great at general knowledge, explanations, and reasoning, but not reliable for company data, latest updates, or private documents. Now let's level this up with something called RAG, Retrieval Augmented Generation. Here, we don't rely only on the model's memory. We connect the AI to external data sources like databases, PDFs, documents, APIs, or internal files. Before answering, the AI first searches the relevant data, then uses that information to generate a response. This is how modern AI apps actually work in real companies. Let's compare these two side by side. A standard LLM is like a closed book exam. It answers only from memory. A RAG-powered AI is like an open book exam. It looks up notes, documents, and data first, and then answers based on that. This makes RAG systems more accurate, more trustworthy, and much more useful for real-world business problems. In simple terms, RAG is a search engine plus an AI brain. Search finds the right information. The AI brain understands it, reasons over it, and explains it clearly. This combination is what makes AI systems smarter, safer, and actually usable in production environments. If you want to work in AI roles today, understanding RAG is no longer optional. It's a core skill. Let's quickly look at the RAG workflow end to end. Step 1, the user asks a question. Step 2, the system searches for relevant information from connected data sources. Step 3, that retrieved information is passed as context to the LLM. Step 4, the LLM uses both the question and the context to generate the final answer. This simple 4-step flow is the foundation of most real-world AI applications today. Now that you understand the workflow, let's break down how a RAG system is actually built, step by step. Don't worry about tools or code yet. Focus on understanding the logic. Once this logic is clear, learning frameworks like LangChain or Llama Index becomes much easier. Step 1 is building the knowledge base. This is where all your trusted information lives. It can include PDFs, Word files, websites, Notion pages, databases, or course content. But large documents are too big for AI to understand at once. So we break them into smaller, readable chunks, usually a few hundred words each. This step is critical because the quality of your data decides the quality of your answers. AI models don't understand text directly like humans do. Instead, we convert each text chunk into something called an embedding. An embedding is a vector, a list of numbers, that represents the meaning of the text. Similar meanings end up with similar numbers. You can think of embeddings as meaning translated into numeric form, so that computers can compare and search efficiently. Once embeddings are created, we store them in a vector database. Unlike traditional databases that look for exact matches, vector databases are designed to find similar meanings. This makes search extremely fast and context-aware. Popular examples include FA, ISS, Pinecone, Weaviate, and Chroma. This database becomes the memory layer of your RAG system. Now comes the search step. When a user asks a question, we convert the question itself into an embedding. That embedding is used to search the vector database. This is called semantic search. It finds information based on meaning, not just keywords. As a result, the system retrieves the most relevant text chunks, even if the wording is different. This is the most important step for accuracy. The retrieved text chunks are directly attached to the prompt sent to the LLM. The prompt clearly tells the model, answer the question using only this information. This grounds the AI to real data. The result is responses that are focused, accurate, and verifiable, not guesses or hallucinations. So, why is RAG such a big deal in the industry? First, it allows AI to use the latest and even private data. Second, it significantly reduces hallucinations. Third, you don't need to retrain models every time data changes. It's cheaper than fine-tuning and highly versatile across use cases. This is exactly why companies prefer RAG-based systems in production. RAG is already everywhere around you. AI tutors use it to answer from course material. Companies use it for internal policy chatbots. Customer support bots rely on it for accurate answers. Interview prep assistants, legal tools, and medical Q&A systems all depend on RAG. If you want to work on applied AI systems, these are the problems you'll be solving. Let's tie everything together. First, documents are prepared and chunked, then embeddings are created and stored in a vector database. When a user asks a question, the question is embedded and used to perform similarity search. Relevant chunks are retrieved and sent to the LLM. Finally, the LLM generates a grounded, accurate answer. This complete architecture is the backbone of modern AI products. To help you move forward, we've shared a cheat sheet and useful resources in the description. Don't forget to like, share, and subscribe to stay updated. In the next video, we'll dive into MCP, Model Control Protocol, and how it helps manage and control AI systems at scale. See you there.